So I'm back. Hopefully you're back as well. Not sure if necessarily we can convert this into something that can be used for the Mac, because I know I was having problems getting it to load on my computer. So we'll have to see what I can do. Hopefully there's something at school I can use to convert it tomorrow for those of you who might have difficulties. But here we go for the second part. We are talking now about estimating the limit of, as x approaches 4, of x squared minus 16 over x minus 4 using a graph. So now we're going to actually graph this. And again, we would graph the function using a table, make an XY chart, plug all the numbers in like we would normally do. And as I look at the particular graph, you should notice this time, because of the number that we have, we're going to end up with something with a discontinuity as x approaches 4. Because when I look at it this time, if I were to put a 4 in there, obviously I would have something where it would not be real. It would be something that would be undefined. So if I look, as we get closer and closer to 4, we're going to see what happens. And they say that it approaches 8. And if we look at the graph, we can in fact see that as x approaches 4, remember we went 1, 2, 3, 4 over here. So now we're looking at 4 over in this way. If I look right there, I can see that it will be at 2, 3, 4, or 2, 4, 6, 8. So our y value is going to be 8. So we can see that the limit is going to, in fact, approach 8. But notice that even though the x and the y values are that, it's not necessarily going to be the same thing, because I can see that there is a discontinuity right there on the graph. So that's going to make it just a little bit different. But still, I am looking not exactly at 4, because the limit doesn't really care what's happening at 4. It's as it's approaching 4. So that's why we're really not too concerned that there's a discontinuity there. If I were to look at my table, again, I would put in 3.9 and 3.99 and 4.001 and 4.01. And again, I'm not caring too much about all those values, but I'm looking to see what's going to happen as I get close to 4. And if I look in between these two y values, we can see that the y value in between those two is in fact 8, which is our limit. And that's exactly what that says there. The pattern of output suggests that as x gets closer to 4, f of x gets closer to 8. So if I look at the table, or if I look at the graph, I still get the same thing as saying that my limit is going to be 8. And this is basically the independence of limit from function value at a point. Basically what that says is, if I have something that as I'm approaching c is the value that we're looking at in all of these different graphs here. If I look at c, as x gets closer and closer to c, my limit will be L, even if there's a discontinuity. Here, there's a discontinuity, and it even has a value that jumps up. But still, I'm caring about what happens as x approaches L from the left and from the right. So since I'm coming from the left and from the right, I really don't care at exactly what L is, but I care about what it approaches as it approaches it from the left and the right. So my limit is in fact L, even if I have a discontinuity or if I have a jump discontinuity. And you can find this information in your book as well. I can also have what's called a left-handed limit and a right-handed limit. A left-handed limit means that I'm approaching a number from the left, meaning from the negative side, which is why there's a negative side here. So the limit would be coming as I approach from the left side at that particular point in time. I could also have a right-handed limit. A right-handed limit is when I approach something from the right, meaning the positive side. So I would be looking as something approaches it coming in that direction. Notice that here I have c from the right, so that's the positive value. So if I look at a problem that is something like this, oh, sorry, I forgot that we have existence. In order to have an actual limit, I need to have my limit as it approaches it from the left and the limit as it approaches from the right needs to be the same number. If they are the same number, then that means the limit exists. If they don't approach the same number, that means the limit does not exist. Oops, wrong way. I'm still having problems. Not much different from being in my class, huh? So if I'm estimating each 1 and 2-sided limit, if it exists, if I have f of x as x approaches 1 from the left, So that tells me it's coming from the left. The negative sign is after it, so I'm not talking about positive 1. I'm talking about 1 coming from the left. So all the numbers that are smaller than 1. So as it approaches it from the left, that means x is going to be smaller than 1. So I would be looking at the top part of the graph. So negative x squared minus 1. So if I'm going to be looking at that particular part of the graph, that's going to be a parabola. So if I look at my graph would be over here. So as x approaches negative 1 from the left, that means I'm looking at this portion of the graph right here. And as it gets closer and closer to positive 1, I notice that my y value is going to be at 3. Oh, sorry. One more time, negative 2. So that means that my limit as x approaches negative 1 from the left is negative 2, that y value that's right there. And then I could have the next question would be the limit of f of x as x approaches 1 from the right. That's what that means down there. So if I'm looking at that one, then I'm looking at the graph on this side. So I'm looking at the positive values, the larger values of x, and that would be over in this part of the graph. And as I approach 1 from the right, that means I'm coming down this way, and that y value would be 1, 2, 3, would be 3. So that's why the limit is 3. Notice that the limit of f of x, the plain value of f of x, when I take it, does not exist, because if the top one equals the limit of 3 and the bottom one equals a limit of negative 2, if they don't approach the same thing, that means the limit does not exist. So now I have the same basic idea here. I have the limit of g of x as x approaches 0 from the left, from the right, and at 0. So if I look at that, I can look at my graph, and here's my graph. If I'm looking at g of x as x approaches 0 from the left, that means I'm looking over at this side. And if I look down here at 0, it appears that the graph is at negative 1. So that's the limit as x approaches 0 from the left. So that's negative 1. If I looked up here as x approaches, if as x approaches 0 from the right, that means I'm looking coming at this way. If I look coming this way, I can see that again, the y value as x approaches 0 from the right is also negative 1. And since from the left and from the right is the same number, that means the limit of g of x is in fact negative 1 because it approaches the same number. I can also look at the limit of f of x as x approaches 2 of 1 over x minus 2 squared. Look at this graph. My graph here, it goes up. And if I look at 2, which is where I wanted to find my limit, it goes straight up to infinity. That means as x approaches 2, and if I were looking as x approaches 2 from the left, or if as x approaches 2 from the right, I would notice that both of them go up. So that means my limit is going to be infinity because it goes up as x approaches 2 from the left and x approaches 2 from the right. Since they both approach the same thing, meaning they both approach infinity, that is in fact my limit. And that is exactly what this says here. If I look at my table has a whole bunch of values, and as I get closer and closer to 2, that gets really, really large right in here. The same thing as x approaches from the right side, that also gets really, really large. So that means that's going to show again, mathematically, that it's going to be 2. Or sorry, that at 2, it's going to be infinity. And that's exactly what that says too. So now I have the same idea. I'm doing the limit as x approaches 0 of 2 over x cubed. If I were to graph that, I would get this graph that's right here. And if I look at the graph as x approaches 0 from the left, meaning this side, I can see that it's going down to negative infinity. And if I look on this one, as x approaches 0 from the right, this limit is going to positive infinity. So that means the left-handed limit is negative infinity, and the right-handed limit is positive infinity. So since they're not the same thing, that means the limit as x approaches 0 does not exist because they're not the same thing. And that's exactly what this says here. Neither of them exist at the left and the right. So that tells me that since this one's going in a negative direction and this one's going in a positive direction, that the limit does not exist. And that's kind of what that says there. Next one, we can also do the same thing with sine, cosine, and tangent. If I were to graph x sine x, I would get this graph. And we want to know what's going to happen as x approaches 0. I could approach x from the positive side, which would tell me I'm coming this direction, which would be the limit coming from the left would be, sorry, that's right, coming from the right would be negative. And I can also have the limit coming from the left, which would also be 0. So both of them have a limit of 0. So since the limit coming from the left and the limit coming from the right is both 0, that means that the limit is in fact 0. They're the only times that I could have where limits don't exist is if I have two numbers that come from the left and the right, a left-handed limit and a right-handed limit, and they're not the same. Then that tells me that I do not have a limit. That's where it would not exist. I could also have it if it increases without bounds. That means one goes to positive infinity and one goes to negative infinity. That tells me that, again, it doesn't exist. And the other option I could have is when it oscillates between two fixed values. So if you can imagine having a sine or a cosine graph, and if we take the period and we make it really, really small, it would oscillate between +1 and -1. That's what they mean, because you can't tell whether it's going up or it's going down. So since it's a sine graph and it's going up and it's going down like that, we're going really, really, really like this, of obviously having the same amplitude. If that were the case, then that tells us we don't know what the value is. So that would tell us that it's also not existing. And then I can talk about limits happening at infinity. So I can see what happens as I go far out to the right on my graph or far out to the left on my graph. So I could talk about the limit of f of x as x approaches negative infinity or as x approaches positive infinity. So if I have this graph and I have the limit as x approaches infinity of 1 over x plus 1, I would graph that. So there's my graph. And if I want to know what's going to happen as x approaches positive infinity, that means I'm going to be going out this way on my graph. Notice that I have an asymptote. Since I have an asymptote there and my asymptote is at +1, that means my graph is going to get really, 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 really close to +1, but never touching +1. So that means that's my limit. And I can also have that shown by using a graph, by using a table. And as I see the numbers are getting really, really small, as they approach closer and closer to 1, my decimals are getting really, really small. So that tells me that my limit is approaching 1 as well. Here's another one where I have a graph. The graph is cosine x. And if I were to take cosine of x and increase it so that I would go forever and ever, I wouldn't know whether it's going to +1 or -1. So since I don't know whether it's going from +1 or -1, we can say that the limit does not exist because it just keeps oscillating. And I can see that it goes from +1 and -1 if I'm talking about putting it into a table. So since it's going between two different numbers, the limit does not exist. And that's all we have for today. Hopefully everyone was able to see it and understand it. Try those few problems that are in your book that I gave you on the Google document so that way you can see if you know what you're doing or not. We'll practice some more in class, and that way you can ask questions. If you had questions as you were going through this, make sure you jot them down so that way you can ask, and we'll see how this all works. Bring me your questions and concerns, and we can see how we can make it better for next time. Thanks. Good night.